Hi course mates and Sir Baggy. Today I'm going to present my paper entitled HPS-Based Teaching as a Tool to Correct Students' Misconceptions and Improve Learning in Physics. The objectives of this paper is to convey the positive impacts of HPS-based teaching and how misconceptions can be reduced in quantum mechanics and electromagnetic theory. Second, how HPS-based teaching can develop problem-solving skills in inclined plane, simple pendulum, and Atwood machine problems. So, what is misconception? According to Atasoy and others, all individuals from all learning levels acquire non-scientific beliefs from their culture or everyday experiences about the concepts found in physics and other areas of the discipline. These non-scientific beliefs are also labeled as misconceptions, children's science, alternative frameworks, common sense concepts, alternative conceptions, or preconceptions. The next question is, why is there an immediate need to address misconceptions in physics? First, misconceptions affect how students process new ideas introduced to them. Second, students integrate some sort of misconception into the concepts that were newly taught to them. Third, misconceptions found in students about physics are not easy to change. Thus, experts exert effort to address these misconceptions using various teaching approaches. Now, why integrate history and philosophy of science, or HPS, to science teaching? The integration of history and philosophy of science in teaching science had long been accepted. Also, complete understanding of the concepts are needed to develop higher order thinking skills and achieve a complete understanding of the nature of science. And numerous empirical evidence shows that integrating historical information of science and discussing experiments done in the past leads to positive effects in science learning. So, what are the potentials of HPS? First, it can develop students' interest in science. Second, it encourages positive attitudes towards the history and philosophy of science. It also aids in the formation of the correct understanding of science concepts. Fourth, it promotes appreciation of science as a procedural field. Fifth, it promotes argumentation skills and learn to express. And last, students can formulate authentic point of view about the epistemological, social, and methodological structure of science. So what are the misconceptions in quantum mechanics and its relationship with HPS? Misconceptions in introductory mechanics are often described as preconceptions because they result from the everyday experiences and observations which begin from childhood, when everyone learns how to walk along the street, chew food, or throw a ball into the air. While the cause of quantum mechanics misconceptions was not clearly attributed to everyday experiences. So some of the quantum mechanics misconceptions are: first, particles can be in more than one place at the same time. Another misconception is that the Heisenberg uncertainty principle is due to technological limitations. And that there are also misconceptions that everything can happen because of the term quantum physics. Also, there are misconceptions about the dual property of light and about electromagnetic induction. So what are some ways to reduce misconceptions in quantum mechanics using HPS? For example, the dual nature of light can be discussed by going over the debate about Newton's corpuscular theory and Huygens wave theory. Another, the discussion of the Fermi-Dirac distribution can be made interesting by starting with the history of deriving the formulas and equations. A study conducted by Nias and others probed the understanding and found out that the freshman students can acquire an in-depth understanding of science practice and development when introduced to new concepts through the perspective of history and philosophy of science. In the study, the control group was taught using the traditional method, while the experimental group of students participated in a classroom discussion where arguments, counter-arguments, and dialogue was carried out with the HPS context. Results showed that only 5% from the control group and 37% from the experimental group are consistent in their responses and provided conceptual feedback, meaning the students from the experimental group were able to provide conceptual feedback, which means they have reduced misconceptions and thus improved their learning. Also, it should be noted that there is a significant difference between the conceptual responses of the experimental and then the control group. Another study that probed the possibility of reducing misconceptions in quantum mechanics using HPS was done by Nashon and others. They gathered the perspective of pre-service physics teachers in utilizing HPS to improve scientific literacy and undertake misconceptions in quantum mechanics. The study shows that students find it possible to use HPS in the topics of the evolution of atomic models, the dual nature of light, Millikan's photoelectric effect, theory of special relativity, fission and fusion nuclear reactions, electricity and superconductivity, and Bohr's atomic structure. In the study, it is suggested that there is a need to remove the misconception of students that only geniuses can excel and formulate science laws and theories, thereby creating a positive impact on science and also in the society as well. For example, the life of Einstein. We can point out that his eagerness to learn physics and not being a genius that leads him to the establishment of his well-known theory of relativity. Next, we have electromagnetic theory and HPS. She, in 2015, conducted a study and enumerated in a chronological order the scientists who have a significant impact and contribution to the field and theory of electromagnetism. It started with Faraday, who stated that when a magnet moves in a coil of wire, it will induce a flow of current in the wire. He also proposed in 1845 that the electromagnetic phenomena were caused by field and field lines that occupy the surrounding space. Then we have Maxwell, who published his paper that contained the full set of equations that governs electricity and magnetism. Also, we have a group of scientists called the Maxwellians. This is the label of the scientist who modified and expanded Maxwell's ideas. First, we have Oliver Hiveside, who showed the reduced form of the equation presented by Maxwell. After Hiveside is Fitzgerald, who used Maxwell's ideas to give credence to McCullough's work in optics, which was not held with high regard at that time. Followed by Lodge, who drafted two papers where he described his creation, the mechanical model, which mirrors the electrical phenomena that were based on Maxwell's theories. Next, we have Hertz, who conducted a well-known experiment which demonstrates the existence of electromagnetic waves. And lastly, and the last to join the group is Marconi, who was successful in transmitting wireless radio signals from as far as 2,000 miles. According to Shea, there are extensive evidence that most difficulties encountered by students in learning physics, especially the electromagnetic theory, are akin to those experienced by the scientists during their discovery of new physical concepts. Students might have a better understanding of the philosophical nature of science by realizing the philosophy employed by early scientists and compare it to the philosophical investigation used by current scientists. Lastly, we have problem solving in inclined plane, simple pendulum, and Atwood machine and HPS. We know that problem solving is one difficulty that students need to overcome to understand physics topics, especially in the introductory courses of mechanics. According to Matthews, the force could not be experienced, which is a fact that could lead to student difficulty when dealing with introductory physics. This difficulty can be simplified if it is demonstrated using the incline problem. Also, Coelho in 2012 pointed out that various problem-solving approaches came from the history of science and largely depended on every foundation of the theory. Consolidating the studies presented, we see that HPS can transform classrooms into a more challenging and intellectual environment, thus enhancing the critical thinking skills of the students, and also it contributes to a complete understanding of how the nature of science works. It can also overcome the views of students in science as a world of equations and formula that they don't know the meaning, and HPS can humanize science. Several studies are successful in showing that HPS integrated physics teaching would generate positive conceptual responses from the students, thus has the potential to correct students' misconceptions or preconceptions. Also, problem-solving skills can be enhanced if teachers integrate the history of each theory and the problem-solving strategy that was employed in the past and in the modern times. Lastly, HPS context will help the students realize that they do not need to be a genius to understand everything around them, and the formulation of new concepts is a series of trials and errors. Thank you for watching and have a nice day.